Hello and welcome back to the channel. You know when you've got a project on the go and you say I'm going to get that done by Christmas? Well, with these big things I stopped saying that many Christmases ago. But with Christmas coming up I thought it was only fair to give you an update on where I am with this and how close we are to getting the cylinder blocks fitted onto the main part of the engine. The main offending item that's held me back with this so far recently has been that Land Rover with the Meteorite engine in it, so you could call that project creep really. It's not a very good idea to have more than one major thing going on at once. I had a problem with the cam drive on that. I had to have a lot of it apart, put it all back together, and I'll do a video about that at some point. So let's have a look at these blocks, see what I've done with this one and sort of how far I am from getting them ready to fit onto the engine. So I'll just talk a little bit about the blocks themselves. This rail, see running along the exhaust side of the block here, is where the coolant comes in from the main coolant pump on that connection underneath there. See the liners there, and it travels up, across and along to the front of the engine, and it exits there out into the coolant header tank. There are 4 valves per cylinder. The 2 on this side are the exhaust valves, and there's the exhaust port on the outside there. Those exhaust valves are sodium cooled, which is certainly unusual on an engine of this age. Became quite popular in the 1980s when turbo cars were really on Formula 1 engines and high performance car engines nowadays as well. And the seats have deposited on them either Bright Ray, which is an 80% nickel, 20% chrome alloy known as a mnemonic, and they use that for jet engine blades as well, or Stellite, which is a cobalt chromium alloy. And here are the intake ports. You can see the 2 valves for that cylinder there. Now the Merlin is very unusual in one respect because it doesn't have separate ports. So if you look, there's a division there in between the 2 valves. And then there's this deeper cutout here if you look along. And these are in groups of 3. So you've got 1, 2, 3 cylinders, and then there's a division there between them, and then you've got the next group of 3. Now, it's virtually unheard of to find an engine that has ports that are Siamese in that way. Certainly a high performance engine, but actually when I check the firing order on this one, what it does is it fires one of these 3, then it'll fire a cylinder on the opposite corner of the other bank of the engine, then it'll fire one of these 3 over here, then one on the opposite bank, before it comes back to fire another one of these 3. So you're not actually firing sequential cylinders out of this group. So, because if you were, one of the cylinders would be taking the air away from one of the others, and that's the reason why not only do they have separate ports on cylinder heads on most engines, but they actually have intake runners, even with carburation, of a certain length, which separate one cylinder from another. So it's quite an interesting thing, and when people modify these engines for fuel injection, they actually have to make a piece that goes in between there, then you put a plate across them, and they actually have separate tubes, if you like, coming out from each cylinder. As you can see, it's a single piece block, and these were in use up until this Mark 20 engine and also the Merlin 45 series for the Spitfire Mark 5. After which they introduced a separate head, but actually this casting goes all the way from the bottom of the cylinder liner right the way up, and it includes the cylinder head, and there's no external joint in that casting, it's all one piece. It's quite a large casting. I had problems with sealing at the head joint, and you can see where the head joint in there is, where I've removed one of the cover plates, and this clamp has a stud running down through this gap in between the 2 ports, and it's just there's one of these on either side to help pull the liner up, and the rest of the clamping force which seals your cylinder head joint is the cylinder head holding down, or cylinder block holding down studs which go through these holes, and you'll see this when we're fitting them onto the engine. But like I say, they were problematic, and they were running into more and more problems with the sealing of the top of the liner into the cylinder head combustion chamber, and they were okay for boost pressures up to about 14 psi, and then they became unreliable, and in fact they changed the 300-hour overhaul period of these engines down to 200 hours as well. This is the induction manifold which fits onto the side of the cylinder head. You can see that the two groups of 3 cylinders here are then split into 3 separate ports fed from the main induction trunk that runs down the middle of the engine and fed from the supercharger. The reason it was split into 3 separate inlets is to allow access to the spark plugs on the intake side of the cylinder head, you can see here. This feature here is called a flame trap. This was introduced quite early on the Merlin Mark II. You have a compressed fuel air mixture coming from the supercharger, and that runs all the way along the induction trunk and into these ports into the engine. At lower boost pressures it doesn't really cause a problem. However, by the time you get up to about 15 psi above atmospheric pressure, if a flame or a spark comes out from the engine back into this pressurised fuel mixture in the induction system, if it ignites, you get a pressure from the combustion of about 200 to 220 psi, something like that, which is enough to blow the thing to pieces or to blow the supercharger up. So the flame trap works extremely well. They did have problems with them much later on when they were running Merlins and Griffons in particular at 18 psi and over, up to 25 psi. You could occasionally get damage to the induction system caused by what they call in the manuals a blowback, and that's basically either a flame or a spark perhaps passing through these tiny little holes in here. Now these are made up of separate foils, one next to each other. You'll have a flat one and then a zigzag one, and I've got a drill here. I've just tested this idea out, and you probably can't really see it, but that drill bit is 0.6 millimeters and it just goes into one of those holes, okay, but only just. So it's full of 0.6 millimeter sized holes. And just to show you how tiny these holes are through here, if I switch the light off up there, right, okay, I've got a really bright torch here, really bright, okay, LED thing. If I bung that on there, you basically can't really see any light in there. Let's just move this. There's just a tiny bit of light, and we can see that, yeah, inside there, okay. See? That's how small those holes are. The principle of the flame trap is most commonly associated with the Davy miner's safety lamp. But that was actually based on the work of George Stephenson, and coal miners in the northeast of England used his design, called it the Geordie lamp. So here's a nice before and after comparison. Obviously in the top end of the engine you can see it's quite oily, but in actual fact all I've done with that little area there is just sprayed it with brake cleaner and wiped it over with a cloth. And there isn't a lot of oil deposit in the top end of this engine, but compared to the bottom end, which was very clagged up with black oil, which is quite common on these engines. However, that means to me at least that this has had a block change, and an interesting point about that is they used to change cylinder blocks over out in the field. There are pictures of them up on a scaffold taking cylinders off with the engines installed on heavy bombers. But this one, as you can see if we look in there, that says 54967, so that's got the engine number stamped on it, which means that these blocks were taken off and overhauled in a factory and then put back on. I mean, I was well aware when I took the engine apart that it had had more than one overhaul, I suspect. But they clearly did a block overhaul on it and not a bottom end at one point. Interesting, you know, just parts of the history of it. This here, this is a piece, it's great, it's a piece of the peat that the whole thing was buried in at one time. Now, it's clearly come from inside here. How it got in there, I'm not honestly sure. Bit of a strange one, that. But of course, you've got to bear in mind, this is really waterlogged. It's bone dry now, it doesn't weigh anything, but originally a lot of water came in with this. Fascinating, that, actually. Let's get rid of that. I'm hoping to get some of these spark plugs going again. I took them out of the other cylinder, cleaned them up, and I'll put them on test. I'm sure some of them will go. So here's the view into one of the liners. It looks absolutely awful, doesn't it? But wait till you have a look at one of the ones that I've cleaned up and honed, because you'd be surprised. You can see that the piston in this one was near the bottom. Some of these cylinders were full of water and it was absolutely clean water that came out, and I suspect it had been in there since day one. So corrosion on the piston rings had probably held the water in there. That one's definitely had water in it, you can see that, but actually the finish on the liner down towards the bottom end of this is amazing, pretty good. I've not so far found any liners on the engine which I'm going to have to change. And this is one of the typical liners on the block that I've cleaned up. You can see on this one, because you can actually see where the piston ring marks are on it, the piston was right at the bottom of the bore, but actually all those marks on there are smooth when you run your finger over them. There are little bits of corrosion pitting in places on it, but I've run engines like this before and they might consume a tiny bit more oil, but actually with this engine I suspect it's probably going to be okay. They don't produce visible smoke, they burn an awful lot of oil anyway, these engines, so. But it's surprising, I mean it's just discoloration in there, which I'm not going to try and take off either. And of course all these valves have been lapped in now as well. And another feature on the inlet manifolds of these engines is the 4 fuel atomizers. There's one there, one down there on the other end, and there's also one on the elbow from the supercharger. And this is one of the jets that's been removed from the other side of the engine. There's a filter in the top there, little gauze thing, and then there's a little atomizing jet on either side there of the part that sticks through into the induction system. And you basically prime the engine with those. Because the carburettor's so far away and so low down on the engine, you don't actually draw a fuel air mixture into it when you're cranking the engine over. So you have to prime it with these things up to a pressure of about 100 psi to atomise the fuel. One thing, by the way, about these gaskets, you can see on here, this orange coloured gasket material, that's got asbestos in it. So if ever you are stripping one of these engines down, and I can tell you, these things stick like the old proverbial to a blanket. I can tell you, do not come off easily, these gaskets. And there's always a temptation there to get the drill out and the wire brush, but definitely don't do that. Scrape them off. Paint stripper dissolves this gasket as well. Always wear a mask when you're doing it, because they are potentially dangerous if you start trying to take loads of these things off, but they are awful things to get off. Great gaskets, I must admit, but terrible. So bear that in mind on stuff that's this old. They used asbestos in loads of things. Right, so I'm going to whip 4 of the valves out of the end of this cylinder block. So I've got this block of wood here which I put up inside the cylinder to hold the valves in place. Tip the block up. I'm going to tap these to separate the tapered collets a little bit. Then we've got the valve spring compressor which goes on here. These are the camshaft assembly retaining studs normally. Okay, and then we just push down on there, pop the 2 collets out, and the whole assembly comes up. It's actually a lot easier than using a conventional automotive valve spring compressor where you have to put it around the cylinder head, and of course you can't do that on here because it's extremely deep, it's not got a separate head. This is the exhaust valve. And double concentric springs. I found on the other cylinder block that I actually had to change some of them due to corrosion, but not very many. Most of them were fine. Then we adjust this tool out to that position. Same thing again. There you go, easy as that. However, what they did was, they also put, these are sticking, these valves, as you can see, they also put a tiny little snap ring just there, which prevents the valve falling in. Now, there's a tool which screws into the spark plug hole down there, which goes up and it holds the valve in place, and you can actually change the springs on a complete engine without having to remove the cylinders. And I think these rings were put on so that if you didn't hold them correctly, it stops them dropping into the cylinder. Because if you get a dual valve spring failure on one of these engines, that little snap ring does not stop the valve going down. Because the piston has a dished crown, it hits the edge of the valve, and with the speed that an engine runs at, it bends the valve stem, pushes the guide out, and then the whole assembly just goes down into the cylinder and gets mulched. So, in fact, later on the very last versions of the Merlin, they didn't put that snap ring in, and they didn't put it in on the Meteor tank engines either. So, I'll take this off. And they're an absolute blighter to get off. I'll show you one of them. And then I'm not going to video doing the rest of them because I don't want to have too much swearing on here, because on YouTube you have to say if it's suitable for everybody to watch. And it won't be. Here we go. That's it, just off that. I'm intentionally doing one of the exhaust clips because they are easier to get off. I probably should have devised a special tool for doing this, to be fair. Right. Actually, I said the valves were sticking. Of course, they're sitting on that block of wood, so that isn't necessarily true. So I'm now going to pop it over, take the block of wood out, and just take one of these valves out. Oh no, they are sticking, yeah. So let's just tap that. There we go. Right, pop it back up. So there's one of the exhaust valves. You can see what I was talking about now with the fact that this cylinder block had been overhauled, because there's virtually nothing in terms of deposits on that exhaust valve. They get a lot worse than that. So I'll just clean this up and we'll have a look at it. So there we go. That's the valve cleaned up. And in fact, it'll just need lapping with fine valve grinding paste, because although it's got marks on it, again, like the liners, it's smooth. Not all of them are necessarily like that. I mean, on the other cylinder there were two valve seats which were quite heavily pitted, and they didn't need recutting, but they had to have a lot of lapping done on them. Apart from that, they were all fine. They cleaned up really well. So, only 23 more to go, and a load of paint stripping, and we'll see what it all looks like. So I can explain a little bit about why they had so many problems sealing the combustion chamber on this type of cylinder block. There's a flange on the bottom of each of the liners there. Now when it's the other way up on the engine, this thing contacts the crankcase, and the pressure from this thing being, the block being attached by these studs onto the crankcase, doesn't go onto this face here because there's a gap underneath this flange. It actually goes all the way down to the combustion chamber, which is what you'd expect, and there's an aluminium sealing ring in the far end of there. And that means that even if you assume that the crankcase surface is flat all the way along, which it will have been when they manufactured it, of course, you've also got to consider the fact that each of these combustion chambers, when you go in there and machine them, and here's one of the cutters which I've used to reface some of these on these engines in the past, they all have to be exactly the same depth. And then the liners would all have to be exactly the same length between the face of this flange and the top of the liner plus the aluminium sealing ring. And the liners themselves are graded into different lengths, but the specification on the drawing means that when the liner isn't in there, you use this tool, which is surface ground on the top and bottom. You put it down there, and then you put a DTI gauge or a clock gauge on the 4 points on the top of it, and so that tool reflects any misalignment down there in the combustion chamber. It's just easier to do it that way. And the spec on the drawing is 1/4 of a thousandth of an inch, so 1/4000th of an inch, whatever that is in millimetres, and variation over those 4 points. Now when I've machined these, I can't get them anywhere near that. It's quite possible that when they had a machine that went down with 6 boring heads simultaneously and did them all in mass production, they probably were able to achieve that. But you've got to bear in mind as well, I mean, aluminium expands and contracts an awful lot, so it's not at all easy to get. But when I've had to remachine these in the past, I've come to them and they were in the order of somewhere like sort of 5 to 8 thousandths of an inch out, or possibly more than that sometimes. And it's quite possible on a milling machine to machine them back closer than that. Down here there are some feet which this block is sitting on at the moment, which again are surface ground, top and bottom. They fit onto the facing for the camshafts, which is also parallel, but you have to check that parallelism when you put this on the milling machine. But that enables you to clamp it down and do the machining. So as I said before, we've got this cutter which is used to reface the combustion chambers, and then this thing which is used for lapping as well, and for finally lapping the surface. There's another lapping tool there, it's quite heavy. Ooh. And various alignment tools as well for the mandrel which holds this cutter and has to be central on the engine. Of course, bear in mind again, these liners aren't fitted at this point in time, you're going straight into the aluminium cylinder. So I hope you've enjoyed this little update. Give it another 6 weeks to a couple of months. I'll have the other cylinder blocks sorted out. We'll be ready to put them back onto the engine. Bill Smith from the Bluebird project has kindly offered to help me with that job because it is a little bit awkward on my own. And then the engine really will be getting towards looking like something which could potentially run before Christmas 2026.